Hello, everyone, and welcome to week 13 of the term. I'm Professor Rios. Hope you're doing well. And this week we move on to Karst topography, which is basically the effect of water and chemical weathering on rocks, underground water, those kinds of things. And of course, a seemingly unrelated, but still part of the shaping the landscape process, basically wind as a geomorphic agent. So let's begin with part one here. Again, these are karst towers that are found in China. China is one place among many that has this kind of topography. It is usually a topography that Florida, for example, in the US would be one such place that has a lot of limestone. As we'll see in this lesson, limestone is very easily dissolved in water. It's just soluble. So these are the lesson objectives, just 3 for this particular part of the lesson. And so let's get going. So carbonation is basically rainwater, to be just as simple as possible. So rainwater is naturally acidic. You mix water with carbon dioxide and you create what's called carbonic acid, H2CO3. Again, that's the mixture of H2O and CO2. Natural rainwater is usually acidic, about 5.5 on the pH scale. Anything above a 7 is basic. Anything below 7 is acidic. Think about lemon juice. Lemon juice would be obviously much lower in this scale. So natural rainwater is naturally acidic. And this combination of water with landscapes often leads to a term called karst. Carbonic acid reacts with calcium and it dissolves it quickly, and limestone is 90% calcium. Limestone, as we learned from a previous few lessons ago, is basically what happens is a type of sedimentary rock that will eventually form when layers of little dead critters sort of fall to the bottom of an ocean, and over the years they collect in layers, and then force is applied to that and you get limestone. If you recall from that lesson, if you metamorphosize limestone, you get marble, which is much harder, right? So limestone is where you tend to find the majority of karst landscapes. Again, sodium and calcium are the two that are going to be focusing on for the most part. Karst processes, again, in order for, water can act on materials like gypsum and dolomite and even sandstone, but most karst develop in limestone type of places. So in the United States, Florida, parts of Texas, Kentucky, New Mexico, and such places, you can find this. There are many places in Europe, like in Croatia, of course, China, in the Caribbean, in places like Puerto Rico and parts of the Caribbean, you find limestone-rich environments. In dry places, karst will form, but it'll be slower because you need water. It's a chemical weathering, so it requires liquid water specifically. And in places where there is plenty of heat and plenty of water, this process happens quite quickly, like in the Caribbean, okay? Or in Florida when it's during the wet season there. When you think about the idea of the role of relief, that means the topography, whether it's steep or flat. Flat rocks slow the underground drainage and karst topography. High relief will cause more of it. So it'll cause for water to roll around in the underground much more quickly. And you get to a very significant degree of karst manifestations, if you want to think of them that way. The role of underground water. Again, it forms the tunnels and the pathways and the places where water is going to flow through. Interestingly enough, you can put in some non-polluting dyes like yellows and greens and pinks, and you can dump them in one place and then see where they come out of. And what that tells you is water has a underground system that is made up of caverns and conduits and underground streams. This is a map, a relief map, meaning topography. And wherever you see lots of little round areas, they are either mounds or they are depressions. So here's a depression, here's another depression, another one. If you really focus on this quite a bit, you find them pretty much all over the place. Temperate. So there are different kinds of karst. There's temperate karst. So that would be found in our type of climate, climates that are warm in summer but cold in winter. These are the kind of features you tend to find. Streams that suddenly disappear, jagged rocks, solution depressions. This is a fancier term for a sinkhole, okay? And again, this is from your textbook. It's a pretty simplistic image, but it gets the point across. You tend to have underground caverns that are filled with water if they are below the water table, or you have caverns that you can go in and explore, hopefully carefully. Sinkholes, depressions, and streams that simply just disappear. There are two types of sinkholes, and sinkholes are either formed as solution sinkholes, and that has sort of the shape of a soup bowl, or you tend to have collapse sinkholes. And these are the ones that look more like a tube. It looks like a cylinder into the ground. And here is a solution sinkhole. This is a pretty old image, but it's a really good image because it kind of shows you what a solution sinkhole looks like. Imagine if there's an unfortunate home here, obviously. But over time, that would level off into a bowl shape. Here's another one, again in Florida. And this is a collapse sinkhole. That's scary. And there are, differences. Solution is it slowly deflates into a bowl. What a collapse sinkhole means is that there's an underground structure and the whole thing above it just simply collapses, forming a tube like what you see here. This happens to be in Guatemala, in Central America. Here's another collapsed sinkhole. I mean, that is truly frightening. Tropical karst. So tropical karst forms rapidly. Again, it's hot and it is humid. Think of an AM climate. Okay, so these tend to they have more vegetation cover, and vegetation will then assist in the transfer or acids, carbon dioxide through the roots. And that also helps in sort of dissolving the material more quickly. And Caribbean karst, think about places like Florida. Florida fits this definition right here. And here's an image of Florida using Google Earth. And if you really focus in, and I highly recommend that when you are looking at this, go on Google Earth, focus on Orlando, for example, and zoom in here. And what you will see is a whole bunch of really, really round circles. And those round circles are sinkholes. It happens to be Florida, so it's a wet climate and they fill up with water. But if you're a home buyer in this area, you have to be really careful because there is a history of sinkholes, obviously, in this region. Caverns and related features. So these are, think about things like a cavern that has a chamber with either hanging stalactites or stalagmites. These are the standing ones. And that's what we're talking about, stalactites and stalagmites. That this is Essentially, what you're seeing here is the solidification of calcium carbonate out of water into something scaly. Think about hard water. If you have hard water in your home and you get that little rock that forms on your faucet, it looks sort of greenish, white. That's what this is. It is calcium carbonate that's coming out of solution from liquid form into solid form. And over the years, it will form these very distinctive features. These are places where you tend to find karst regions. So again, Texas, Florida, Virginia, Missouri, New Mexico, lots and lots of African areas. Here you have them in Italy, Spain, Portugal. They're pretty much found in many, many parts of the world. And of course, here in southern China. Karst towers. These are again cone-shaped and steep. And they look like, it's sort of like meringue peaks if you ever made a meringue pie. I know, I sort of bring everything around to food, but you sort of get the point. Or this one, I think this is a much better one. Again, you get a sense of what you're seeing here is the material that's harder to dissolve hasn't been dissolved, so it leaves behind the harder rock. Because it happens to be a wet climate, it's covered in vegetation. But this is a very, very distinctive karst tower landscape. And here is a very classic one from southeastern China. And that's the lesson. Pretty straightforward, this part of the lesson. We're going to move on to, let me minimize that. And then we're going to move on to part 2, which is wind as a geomorphic agent. So wind is very powerful. In desert regions, as you can see in this image here, wind can do a lot of damage, or it can do a lot of shaping of the land. However, I do want to get across that even in desert regions, the most significant wind shaping agent, the most significant land shaping agent is still water. When water does fall in desert, it can do a lot of work on the landscape. These are the lesson objectives for this half of the lesson. And some of the concepts and terms. So this is, when we talk about wind in any region, but in desert regions, the term that's used is aeolian, A-E-O-L-I-A-N. Anything, when you hear that term, think wind. And wind can do all kinds of shaping of the landscape. And oftentimes, a lot of these processes happen in tandem, meaning together. So you have wind and you have water. Sometimes you may have ice. So it really depends on where. It depends on the climate of the particular region. So the role of wind, whether it's an area like this or like this, or a place like the Taklamakan Desert, which is just north of Tibet. Here's Tibet to the south. Looks like this. So this region here is this. It is thousands of square kilometers of yellow, tan, dust, and sand that have accumulated over millennia. Because you have mountains to the north, to the west, to the south. It's basically all accumulated here. And no one lives in this region. Everybody lives on the edge where the water drains from the Himalayan mountains to the south, to the Tibetan plateau, rather, and the mountains to the north. Okay? And so the role of wind, again, here's a desert in Australia. Wind erosion, so basically sand grains around 0.1 millimeter is most easily moved, and the wind will move sand and dust, not unlike water will do that. The only difference between wind and water is there's no solution, right, with wind. So you can still have suspended stuff, dust. You can have material skipping along the ground, and you can have material being dragged along the ground. All right. So some deserts are rockier and greener than others, like the Mojave Desert in the United States. And deserts occupy about a third of the planet's land surface. So for the most part, and if you go back to the weather block, we're talking about places near the tropics and 30 degrees north or south. Remember the subtropical high pressure? Also cold currents. There's a cold current here. There's a cold current here. There's a cold current here. So the combination of a cold current and latitude leads to arid regions. Other things, for example, near the Andes, it's also the leeward side of the mountains. Remember that from the weather block? If you're on the other side of the mountain, it's dry, it doesn't rain as much, and you get to have deserts like up here in Oregon and Washington State. So in the Atacama, which is in Chile, this is the driest area on Earth by far. And it's a combination of latitude, near 30 degrees. It's a combination of cold ocean water. It's called the Humboldt current. And the wind blowing out of the Amazon. So this area here is super wet, and it's almost immediately next to the driest. And that's because the winds are descending. So in this case, the Atacama suffers from all three reasons why a place could be dry. Okay, here's an example of the Arabian Peninsula. So here you have Saudi Arabia, Yemen, Oman, the United Arab Emirates, and this is all the sand and dust. There's not a tree anywhere to be found, except at the very, 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 very high elevations. Here's a place, this is the Aral Sea in present-day Uzbekistan and Kazakhstan. And so this is an area that has shrunk by a significant amount since the 1960s. It used to be the world's fourth largest lake, and it's basically been reduced by 90%. While this is not a climate change-driven victim, as it were, it's 100% human-caused, because the Soviets diverted 2 rivers to irrigate farmland. And basically they removed the one and only source of water that would keep feeding the lake. Okay, there have been second and third order effects as a result. And basically the fishing industry collapsed. There's a lot of pollution because there's a lot of fertilizer that's now left behind. And because of less water, the winters are colder and the summers are now warmer than they used to be. This is an image from 89, 2003, 2009, 2018. Eventually, the wind will reshape everything you see here. And here you get a sense of what the wind can do. So a particularly windy day, this happens to be winds blowing from the northeast, and it's taking all that dust from here and turning it into a dust and sandstorm here. If there were still water here, there wouldn't be a sandstorm. That's an unfortunate second and third order effect. In places that are dry, without a protective canopy of vegetation, there's no roots to bind dirt together. What happens is the moisture goes away. The soil cannot form because you don't have the organic component. And what you're left with is this. This could be New York, except in our case, we have lots of rain, lots of moisture, trees grow, and in the fall, the leaves fall and they rot and they become part of the soil the next year. And the process sort of repeats over and over and over and over again. These could very well be the Catskills or the Adirondacks. The only difference is here there's no rain, so nothing grows. If suddenly this climate were to change and get wetter, over the years, you would begin to see vegetation come back, and this might look like any forest that you would find in the Northeast United States. So that's basically the difference. This happens to be Afghanistan. Again, here's a roll of wind. So here you see the effect of water. Hopefully that's pretty obvious to you, right? Water flowed through these canyons here, and it opened up into this alluvial fan. Here's an alluvial fan, here's an alluvial fan. But the wind can also pick up a lot of this stuff and move it around. So it acts to erode, transport, and deposit, just like water. And just like water, it can create some very interesting deposits that are pretty to look at, also very dangerous. So the wind transportation is, instead of 4, like with water, you have 3. Again, the only one that's not available would be solution, because there's no water. So it can either be suspended, or it can skip along, or be dragged. This is from Bolivia, the Altiplano, which is the high plains, basically. And here you see how the wind has sculpted, and basically you can see almost the direction that the wind typically blows from, this way, because it's basically chiseled away this larger piece of rock. Transportation and suspension. So this is an area from the Sahel. So this would be just south of the Sahara Desert, but north of the tropical rainforest. And here you see lots of sand and dust that can be easily suspended. Hopefully you see that in the tan color of the sky. Abrasion is, again, the shaping of the wind. Imagine you have a hose with a big compressor, and you can take sand and just blow it out that hose. You're abrading material. And here you can see how the wind over the years has spitted that rock. It's almost like somebody took a little hammer and just started sort of chiseling at it over the years. And it forms landforms called venti. Anything with vent, wind, venti facts. These are forms that are created by the wind chipping and grinding away, sandblasting over centuries. Okay. Again, sand dunes, how they tend to form. So sand dunes, they move around, they accumulate, they sort of reshape. Here you see the wind blowing, makes it to the crest, the stuff falls and spins, and this over time will move in this direction. Okay. And here's an example of above imagery. So you can see the direction of wind. Okay, basically moving this way for the most part. Or here's another image of a much larger dune field. And these are the ones from that desert in the Taklamakan or Central Asia. Okay. Two other types of erosion. One's called a blowout, and another one's called desert pavement. Desert pavement is hard and relatively impermeable, meaning water cannot seep through it. So basically what happens is these bigger pieces remain, but the dust underneath is sort of blown out. And what's left behind is something that looks almost like pavement. Very loose pebbles and rocks that are found there. Okay. Here's an example of desert pavement, and this is from the desert southwest. Again, you have rock covering very, very fine dust underneath. Lows is dust deposits. They tend to be yellowish in nature. Much of it was deposited by glaciers long ago and moved around by the wind. And these are places where you tend to find them in the United States, in the Columbia River Gorge area of Idaho, Oregon, Washington, Nebraska, Iowa. Here's a much better sort of look in the United States, in parts of Africa, Europe, and Asia. So they're found quite a bit. Here's that one desert that we looked at earlier, that little oval, that would be this in just north of the Tibetan Plateau. So that's it. That's the lesson. Next time we get into glacial landforms and landscapes, this stuff isn't complicated. It's just a way of thinking of the world and viewing your world in the sense of how the Earth shapes itself and reshapes itself continually, whether it be ice, whether it be water, whether it be wind, whether it be sand, whatever the case might be. If you have any questions, please come to the live office hour or send me an email. I'd be happy to set something up for you if the normal time does not work. Otherwise, I hope you're doing well, and we'll talk to you soon. Bye.